Hi, I am Dr. A. KESAVA, Assistant Professor, Department of Mathematics and Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. So this is second class. Already previous class we discussed the introduction of probability. Now this class we covered random variables. In last classes we discussed experiments and outcomes, different types of and random experiments, sample space, and some other different definitions, and finally the probability definition. Probability is the number of favorable events to E by total number of events in the random experiment. Okay, that is main important. And some importance of the probability and axiom of probability. Okay, now this class covered random variables. Okay, you see, random variable, a random variable is a variable whose value determined by the outcomes of a random experiment. Okay, it does not mean the variable itself of random. Instead, the value it takes changes depending on chances. Okay, so random variable is a function that assign a numerical value to each outcome of a sample space in a random experiment. For example, it is like a function. So this is already x. X is a sample space, and this is a sample space. This is random variable x. So if you toss a coin, we will get head and tail. We can assign these two as a numerical value. For example, h assigned 1 and tail assigned 0. This is random variable. A random variable is a function that assign a numerical value each outcome of a sample space in the random experiment. In the random experiment, the outcomes are h and t, that is head and tail. So this head and tail is assigned to a numerical value 1 and zeros. 1 means head, 0 means tail. That is random variable. The types of random variable next. There are two types of random variable. One is discrete random variable, another one is continuous random variable. Okay, so now discuss discrete random variable. So the discrete random variable is a random variable x which can take only finite number of discrete values in the interval is called discrete random variable. This is in finite number of values. There are only finite number of values in the interval, that is called discrete random variable. Example, number of heads in 3 coin tosses. So now we will toss a coin, we will get 8 outcomes. Here the number of heads means first time we will get 0 heads, second time 1 head, 2 head, 3 heads. That is, these are the numerical values 0, 1, 2, 3. This is discrete random variable. Number of students absent in a class. Generally, number of absent in a class is 3, 5, like 10, like this. These are the numerical values. If you are rolling a die, so let x equal to outcome of the die rolls. Okay, that is, we can take x, random variable x. The possible values are, if you rolling a die, we will get the values 1 to 6. 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5, 6 are numerical values. So here x is a discrete random variable. These are the examples of the random variable. This all our values are finite values. That is discrete random variable. Okay. Next, continuous random variable. Continuous random variable means it is infinite values in the interval. Okay. So you see that a random variable capital X which can take all possible values in the interval is called a continuous random variable. Infinite values between the interval, that is continuously. Okay, that is. Example, height of the students. Generally, in a height of the students is 155.2 centimeters, 155.25 centimeters, like this. These are the between 140 to 180 between the range. Okay, that is the height of the students, like these examples. Okay, and time taken to finish a task. When you finish a task, we can take some times between 5 to 10 minutes, 30 to 1 hour, like this. These are the continuous type. Okay, Next, so another take example, measuring a person weight. Let y equal to weight of a randomly selected persons. Okay, generally the weight of the persons is lies between 40 and 120. Generally, lower value, the lowest value is 40 and maximum value is 120 kg, like between the number of persons are between the between these two numbers 40 and 120. The possible values any real number in a range is 40 to 120. Therefore, y is a continuous random variable. So the weight of the persons is repeatedly continuously in the 40 to 120. That is continuous random variable. Okay, that is. Next, so why random variables are important in the statistics? So you see that the random variables allows to us convert a real world processes into mathematical models. Okay, that is one. Define probability distributions like binomial, Poisson, normal, uniform distributions. Okay, that is. Compute expectations. Expectations are mean, variance, and standard deviations are like this. So we can use the random variable. That's why the random variables are very important in the statistics. Okay. Next, probability function. So this is the definition of probability function. Probability function. A probability function describes how probabilities are assigned to the values of a random variable. For a discrete random variable, the probability functions also in two terms. One is discrete type, another one is continuous type. First of all, we have to discuss discrete type. Okay, in discrete random variable, the probability function is called the probability mass function. In discrete form, we can take probability mass function. We can call it. Okay, the definition of the probability mass function is if x is a discrete random variable x, the the real valued function p of x is such that this is the important p of capital X equal to small x, that equal to p of x. Then p of x is called probability mass function of a discrete random variable x. Probability p of x gives the measure of the probability for different values of x, measurement of the different values of x. That is probability mass function in discrete random variable. Okay. So the properties of the probability mass function is there are three types. One is probability mass function always positive, greater than or equal to 0. And total probability, sigma, total probability equal to 1. And also p of x is equal to 0 for that are not possible. So probability mass function contain negative values also. Okay, so p of x equal to 0, it's not possible, always some positive values. These are the properties of the probability mass function. Example, let x number of heads when flipping a coin twice. If you coin twice flipped, you will get sample species head, 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 head to tile, comma tile. You will get, if you tossing a two coins, you will get the outcomes head, head to tile, like this. So here possible values are 0, 1, 2. 0, 1, 2 means 0 heads, 1 heads, 2 heads possibility. Okay. Then the probability mass function is when x equal to 0 means 0 heads. 0 heads means you can only tile case. This is only tile case. Out of 4, we will get only 1. That is 1 by 4 chances. Probability is 1 by 4. Next, x equal to 1 means 1 head. One head is here. Here, this is also 1 head. There are out of 4, we will get 2 times. TH or HT. Therefore, 2 by H. Here, TH or TH. That is the probability is 2 by 4. That means 1 by 2. Okay. Next, 2 heads. 2 heads means only here is, this is only H comma HH. That means 2 heads. Out of 4, we will get 2 heads. That is HH. So out of 4 we will get 1. The probability is 1 by 4. Therefore, the probability distribution function is x equal to 0. 0 heads means probability is 1 by 4. 1 head means the probability get 1 by 2. And 2 by 4, that means 1 by 2. And the 2 heads means x equal to 2. 2 heads means you will get only 1, that is 1 by 4 the probability. This is the discrete probability distribution function. Okay, so the outcome generally sample space, so you can toss a coin 2 times, so you will get HH, TH, HT, TH. This characteristic values converted into numerical values, that is 0, number of heads taken 0, 1, 2. The probability of the 0 heads, 1 head, 2 heads is 1 by 4, 1 by 2, 1 by 4. This is the probability distribution function. Okay, that is. Next, some more definitions of the discrete random variables. Okay, first one is expectation. Expectations are mean, mu. Okay, mean. A random variable x takes the values x1, x2 and so on, xn with respect to probabilities p1, p2 and so on, pn. Then the mathematical expectations are mean is defined by e of x equal to x1 p1 plus x2 p2 and so on, xn pn. So you can take summation sigma I equal to 1 to n xi into p of xi. This is expectations are mean of the discrete random variable. Okay, next, variance. The variance of the probability distribution of a random variable x is given by variance of x equal to expectation of x square minus expectation of x whole square. This is also we can write summation x square into p of x probability minus e of x is mu, mean square also. This is also one of the formula. Sigma x square into p of x minus mu square. And the last one is standard deviation. The positive square root of the variance is called a standard deviation. So standard deviation equal to square root of the variance. Variance we will get the standard deviations. These are the important formulas for the discrete random variable. Expectations are mean, variance and standard deviations. Okay. Now we have to discuss some problem. One of the problem of the discrete random variable. You see that a sample of 4 items is selected at random from a box containing 12 items, of which 5 are defective. Find the expected number E of the defective items. So here we have to find expected number of defective items means mean. We have to find mean of the given random variable. Here the total number of items are 12. Out of 12 we have to select only 4 items. In these 12 items, 5 are defective. First of all, we have to find the mean or expected of the given problem. We have to find first of all discrete probability distribution function. You see this is the discrete probability distribution function. First we have to find this table. Here x is the number of defective items, 0 items, 1 item, 2 item, 3 item, 4 item. Like this we have to find 0, 1, 2, 3, 4 values, and accordingly we can find the probabilities of the given values 0, 1, 2, 3, 4, maximum 4. So after that we can find mean of the given problem. Okay, first of all this problem, here number of items is, okay, write down given number of items equal to 12. In these items, five items are defective. Number of defective items equal to 5. So defective items is 5. So the number of good items are, you can subtract from total. So 12 minus 5 is 7. 7 is the good items. Okay, we can write number of good items Good items are 7. Now let us take capital X. X equal to number of defective items. Okay, we can take. Now let capital X denote the number of defective items. Therefore, capital X equal to, we have to select only four items. 4 items means like 0, 1, 2, 3, 4. Let X equal to 0 defective item, 1 defective item, 2 defective item, 3 defective item. Maximum 4 selected, that is 4 defective items. So we can choose let capital X equal to the number of defective items. Now we have to find the probability of the given random variables 0, 1, 2, 3, 4. Okay. Now first of all, P of X equal to 0. That means no defective items. No defective items. Okay, you can apply the formula for, already you know the probability definition, number of favorable cases by total number of events in the random experiment. Here the total number of events in the random experiment means out of 12 we have to select 4, that is 12C4, that is total number of events in the random experiment. The number of favorable cases is no defective items, we have to select only 4. Out of these 4, no defective items, and that means we can select only good items. How many good items are there? 7. Out of 7 good items, we have to select 4, that is 7C4. The favorable cases is 7C4 divided by total 12C4, that is the P of X equal to 0, that is no defective items. Now calculate this one. 7C4 NCR formula, we know that already yesterday we discussed n factorial by n minus r factorial into r factorial. 7C4 means 7 factorial by 7 minus 4 means 3 factorial into 4 factorial. We can write 7 into 6 into 5 by 4 cancel, 3 into 2, that is 7C2. 3 ones are 3 twos are 6, 7 5s are 35. This is 35 divided by next 12C4. What about 12C4? 12 factorial by 12 minus 4 is 8 factorial into 4 factorial. So this can be written as 12 into 11 into 10 into 9 into 8 factorial cancel. The remaining are 4 into 3 into 2. This can also right. 4 ones are 4 threes are 3 cancel. 2 ones are 2 fives are 11 fives are 55. 55 into 9 fives are 45. 450. 11 fives are 55. 55, 9 fives are 4, 10 fives are 45. 495. This is 495. We can also cancel this 5. 5 sevens are 599. 99 sir. That is also 495. Okay. The answer is P of X equal to 0 means 7 by 99. And the second one is P of X equal to 1. That is P of 1 defective items. 1 defective. And out of 4, 1 defective, 3 good items. 3 good items. So this can be written as 1 defective item. How many defective items are 5? That is 5C1 into good items are 7. 7C3. 7C3 divided by 12C4. So 5C1 is 5. 5 into 7C3 calculated same 7 factorial by 4 factorial into 3 factorial, same value 35. 12C4 is 495. So we can also 5 ones are 599. 35 by 99. That is, if p of x equal to 1, we will get the probability is 35 by 99. Next, p of x equal to 2. Here, that is p of 2 defective items. 2 defective items, and out of 4, 2 good items. This can be written as, already the defective items are 5. So 5 means 5C2. We can write 5C2. Good items are 7. We can write 7C2 by 12C4. 5C2 value is, I thought that it is 10. 5C2 means 5 factorial by 5 minus 2, 3 factorial into 2 factorial. 5 into 4, 3 cancel by 2. 2 ones are 2 twos are, that is 10. Yes, this is 10 into, what about 7C2? 7C2 is 7 factorial by 5 factorial into 2 factorial. 7 into 6, 5 cancel into 2. 2 ones are 2 threes are. 7 threes are 21. 21 by, that is 12C4 is 495. Okay, so 5 twos are 599 cancelled. So finally, when p of x equal to 2, we will get 42 divided by 99. That is the probability. Next, p of x equal to 3. So here 3 defective items. P of 3 defective items and 1 good item. Here 3 defective items means 5C3. We can choose 5C3, and 1 good item means 7C1 out of 12C4. This is also 5C3 also, that is 10. Yeah, look at to this 5C3, 5 factorial by 2 factorial into 3 factorial. Yeah, same thing. This is also 10 value. Okay, so 10 into 7C1 is 7 divided by 495. Denominator is 495. Same thing. 5 twos are 599. 7 twos are 14. So this is 14. We will get 14 by 99. Okay, p of x equal to 3 also. And the last one is p of x equal to 4. That is 4 defective items. You can select only 4. That 4 also defective items. So you can select only defective items. That is 5C4 by 12C4. So the value of 5C4 means we can write combination of 5C4, that is 5 factorial by 1 factorial into 4 factorial. 1 factorial is 1. So we can write 5 into 4 factorial by 4 factorial. 4 cancel. We will get 5 only. That is 5 by 495. You can cancel this one also, 99. That is 1 by 99. So the value of the x equal to 4 is 1 by 99. So we can find the probability distribution function. So finally, therefore, the probability distribution function is capital X equal to small x, and probability of p of x equal to, first one is 0, 1, 2, 3, 4. So whenever 1, the value is x equal 0 means 7 by 99. 7 by 99, 35 by 99. 7 by 99 and 35 by 99. And x equal to 2 means the value is 42. 42 by 99 and x equal to 3 is 14 by 99. Okay, and x equal to 4 is we will get 1 by 99. These are the probability distribution function. Okay, so when you find the probability distribution function, you can easily calculate the mean or expectations of the number of defective items. Okay, now we can write. Already we know the expectation formula, sigma E of x equal to sigma xi into p of xi. X is the variable, p of x is the probability. So multiplying both variable and probability, that is the expectations. Okay, the number of expected defective items capital E is E of x equal to sigma x into p of x, that equal to, we can write 0 into 7 by 99 plus and 1 into 35 by 99 plus 2 into 42 by 99 plus 3 into 14 by 99 plus and 4 into 1 by 99. We can calculate this one. 0 into anything is 0 plus 1 into 35 is 35 and 2 into 42 is 84 by 99. 3 into 14, 3 4s are 12, 42 by 99 and 4 by 99. We can calculate, take 99 as a LCM, common value. Substitute this one, 35, 84, 42 plus 4. So adding these values, we will get, right, 35 and 84 is 110, 119, 119 and 42 to 46, 5, 6, 165. So 165 by 99. If possible, we can cancel it, or otherwise we can leave it. So finally, the expectation is 165 by 99. These are the expectations or mean of the given number of defective items. So here we can solve the, so out of 4 items are selected in 12 items, of which 5 are defective. Find the expected number of defective items. After solving this one, we will get the probability distribution table and you can find easily to expectation of the given problem. The expectation is 165 by 99. Okay, we can solve this problem. Okay, and you can use the references of this one, like so fundamentals of mathematics, Khanna publications, probability and statistics, and fundamentals of probability and statistics for engineering, T.T. Singh and John Ville and Sons. Okay, so in next class we can also some more problems. We have to discuss some more problems of the discrete random variable. Okay, thank you.